Good morning, students. Already I explained you about the PN junction formation. So now I will explain you about the application of the PN junction. Okay, application means the use. Okay, in what way we can use a PN junction diode. So here so generally we are using the PN junction diode as a half wave rectifier and as a full wave rectifier. What is the meaning of the rectifier? Rectifier means to rectify the signal. So how to rectify it? Suppose we take one AC signal. If the AC signal is converted into the DC, then it becomes a rectifier. Okay, so we can use the PN junction diode as a rectifier. So here for the first one, the half wave rectifier. So half wave rectifier, I already give you the PDF file related to the rectifier. So for the half wave rectifier, so what we are using? So we are using one transformer. Okay, so we are using one AC signal. We are using one AC signal. We use one transformer. So we use one PN junction diode. So this is the symbolic representation of PN junction diode, and we use one resistor where we find out the output. Okay, so we are finding out the output here. So here we take the AC signal. So this AC signal, if we observe the AC signal, it has two half. One is the positive half cycle, another one is the negative half cycle. So this is the positive half cycle, this is the negative half cycle. So okay, for the positive half cycle, whenever we take the positive half cycle, suppose the current flows through this particular inductor clockwise. If we take the negative half cycle, then it will flows anti-clockwise. So this is the difference. Okay, so if we take the positive half cycle, if the current direction is left to right, then for the negative half cycle, right to left. So here, due to the flow of current, due to the increase of current, change of current, so here magnetic field changes. Magnetic field changes, ultimately the magnetic flux through this inductor changes. Due to the change of magnetic flux in this inductor, it will affect the nearby coil also because of the mutual induction. Okay, due to the mutual induction, the change in magnetic flux takes place here also, and as a result, the change of magnetic flux, here we have the current, that is the induced current through this particular coil. And let the induced current be directed such that the point A is act as a positive, point B is act as a negative. Okay, so it means what? The direction of current is along this direction. Okay, so A is act as positive, B is act as negative. Then if we observe the PN junction diode, then P is connected to positive, N is connected to negative. So ultimately the PN junction diode in forward bias. If forward bias, then we have maximum current through the PN junction diode. And if current flows through the PN junction diode, then this current flows through the resistor also. If it flows through the resistor, then we have the potential drop across the resistor. And if we have the potential drop across the resistor, then we have the output. Okay, so I repeat it once again. For the positive half cycle, here the change of magnetic flux takes place. Due to the change in magnetic flux, mutual induction takes place. Due to mutual induction, the flow of induced current in the secondary, and then due to the flow of induced current, A acts as positive, B as negative, then the PN junction diode in forward bias, and due to the forward bias, we have the current through the diode. So due to the current through the resistor, we have the potential drop across the resistor, and we have the output. Similarly, for the negative half cycle, For the negative half cycle, now the current in opposite order, again the mutual induction takes place. Now A is acting as negative, B is acting as positive. If A is negative, PN junction diode in reverse bias. If reverse bias, then very small amount of current passing through in reverse bias, which is neglected. Okay, so it means we are taking no current passing through the diode. If no current passing through the diode, then ultimately no current through the resistor. If no current through the resistor, then no output. So we have no output for the negative half cycle. Again, if we take another positive half cycle, we have the output. If we take another negative half cycle, then we have no output. So it means that we have the output for only one half cycle and which are in the same phase. Okay, so we have the output as DC. Okay, so this is your input and the output voltage graph. We have the output for the positive half cycle, we have no output for the negative half cycle. Again we have the output for positive half cycle, we have no output for the negative half cycle. So this is your PN junction diode in forward bias. Similarly, if we take the full wave rectifier, in case of the full wave rectifier, if you observe the circuit diagram, here again one input signal is present, one transformer is present, two diodes are present. Instead of one diode, here two diodes are present. Then another one resistor where we find out the output. Similarly, for the positive half cycle, due to the mutual induction, A is positive, B is negative. If A is positive, D1 becomes forward bias, D2 is reverse bias. So D1 is forward bias, so current passing through D1, this current passing through the resistor, and we have the output. Similarly, for the negative half cycle, due to the mutual induction, A is acting as negative, B as positive. Now D2 in forward bias, D1 in reverse bias. So D2 conduct electricity, so current flowing through D2, then we have the current, that current through the resistor, and we have the output. So if we observe the full wave rectifier, for full wave rectifier we have the output for the two cycles. So it means that this one is full wave rectifier. So here the diagram is see. So we have for the positive half cycle we have the output due to the diode D1. For the negative half cycle we have the output due to D2. Again for positive we have the output for D1, for the negative we have the output for D2. So these graphs are very important, these applications are also very important. So please go through it, go through the notes, okay, as I given in the PDF file. So these two topics are very important, okay.